Introduction to chemical equations. What's a chemical reaction? It's what happens when you mix two chemical compounds together and the elements in those compounds rearrange to form new chemical compounds. This is an oversimplified version of what happens, but it will do for now. So what does a reaction look like when you mix chemicals together? Well, the first thing you need to know is that all chemical equations take the same basic format. Capital R stands for reactants, capital P stands for products. So the reactants are the things that you mix together, and the products are what forms when the chemical entities rearrange themselves. And that's what happens in a chemical reaction, is that the reactants rearrange their atoms to form one or more different chemical compounds that are called products. So let's take an example. Okay. If you take a look at this equation, this is called a chemical equation. On the left side, we have PbNO3,2. This is lead 2 nitrate. Our second reactant is Ki, which is potassium iodide. Now, in order to figure out what the products are going to be, you have to think about these things as ions. So what we'll do is we'll color code things to make it a little bit easier to see what happens. But before we can form the products, we have to sort of deconstruct or take apart our two reactants. So we need to take lead 2 nitrate apart into the lead plus 2 ion, right? Lead can be plus or minus, lead can be plus 2 or plus 4. We know that this is the plus 2 form of lead because we look on the back of our periodic table and we found out that nitrate is minus 1. If we take potassium iodide apart, look in your periodic table, the oxidation number of potassium is plus 1, the oxidation number of iodine is minus 1. What happens is that these two reactants rearrange in terms of the atoms inside of the compounds. So what's going to happen is that the lead is no longer going to be attached to the nitrate, but the lead is going to get together with the iodine. And what's going to happen with the potassium is that it's no longer going to be with the iodine, it is going to get together with the nitrate. And so this is what happens in a typical chemical reaction, is that the atoms, or the ions in this case, rearrange to form two brand new chemical compounds. Another way of thinking about this particular kind of reaction is to use some alphabet letters. And again, we've kind of color-coded this to make it easier for you to see what's going on. So our first reactant is AB. And remember that the first atom in the compound is our cation with a positive charge, and the second ion in the compound has a negative charge. And remember how we put these together, the cation always comes before the anion. So if we take a look at the alphabet scheme, what happens is that A will get together with D, right? Because a positive and a negative ion have to hook up because opposite charges attract. And C, again, the cation always comes first, will rearrange and get together with B. Again, the positive and the negative ions get together to cancel each other out. So we've talked about reactants, we've talked about products, but what about the arrow that goes between them? Because there's chemistry that goes along with this arrow in the middle as well. And this arrow is called a reaction arrow. If we take a look at a couple different types of chemical reactions, you've got something like an explosion. An explosion is an example of a very, very fast reaction. We've also got, on the opposite end of things, rusting. Rusting is a very slow reaction. This is called the rate of reaction. Chemical reactions can go very fast, they can move very slow, and they can be all things in between. Chemical reactions all take place at room temperature, right? I mean, because that's where we do chemistry, is that when we do chemistry, we do it in a lab, and that lab is at room temperature. Okay? But we can impact what goes on with our chemistry. We can heat things up, or we can cool things off. We could use our Bunsen burner to heat up a reaction. We could use a water bath with ice cubes in it to cool things off. We can add more of something, right? What's the difference between adding 1 teaspoonful of sugar to coffee and 5 teaspoonsful of sugar to coffee? Right? You can always add more or less of something. We can also increase the surface area. If you've got a piece of iron and you want to increase the surface area, you get a very sharp pair of scissors and you can cut that piece of iron into much smaller pieces. All of these different things can impact the rate of reaction or how quickly or slowly a reaction goes. One model that's very important in chemistry and in a lot of science, it helps us think about this, is called the kinetic molecular theory. Simply stated, it says that all things are made of small particles, and those particles are always moving. And so what you're going to do next is visit the Explore Learning website to investigate this concept using a gizmo called collision theory.